Hello everybody and welcome back. Today we are on Unit 5, Lesson number 3, and we're going to be learning about global winds and the Coriolis Effect. So as always, we should have downloaded our interactive notebook pages and we can go ahead and jump into these. So remember, our ocean currents are affected by three things: our winds, the rotation of the Earth, and the location of the continents. And we're going to be talking about each of these more in depth today. So we've talked about how the intensity of the wind and the direction of the wind can push those ocean currents, specifically the ocean currents that are closer to the top, so the surface currents, right? So the surface currents are the ones that are closer to the top of the surface of the ocean. Now, we need to know about the actual wind belts that will actually move our currents. Now, we don't have to know about high and low pressure right now because we'll talk about these more when we get into our meteorology unit, but we do just need to be aware of their existence and kind of the direction that these winds are flowing. So, global wind belts are a major factor that affect the flow of ocean surface water. And there are a couple different types. So the trade winds are located just north and south of the equator. So if we're looking at the middle of the Earth, the trade winds are going to be north and south. The trade winds will blow from northeast in the northern hemisphere. So if we take a look at our compass up here, these winds will be coming from the northeast. So they'll be coming from this direction and they'll be flowing towards the equator. And then in the southern hemisphere, they'll blow from the southeast. So down here is where the southeast is, so in between our south and east. So our winds will be flowing up from this direction. The westerlies are located in the middle latitudes, so between the poles and the equator. And they will blow from southwest, so if we look for southwest here, in the northern hemisphere, and from northwest in the southern hemisphere. Now, the westerlies are kind of easy to remember because the westerlies move in either a southwest or a northwest direction, and that's how they get their names, because they're blowing from the west. So here is just an example of our trade winds and our westerlies. We're not going to worry about the easterlies yet because, again, this is more talking about our weather unit, which we'll get to. And we'll also talk about pressure a little bit more when we get to weather. But we just need to kind of introduce this topic here because these winds do affect the patterns of our ocean currents. So again, we have these trade winds that are right around our middle of our Earth, so right around our equator, that are coming in from our northeast and our southeast. And then we have our westerlies that come from our southwest and our northwest. And they move in this very particular pattern across our globe. And these are going to be the winds that are pushing our surface ocean currents. And we know that that's a major factor in what drives our currents in our ocean. So another factor that affects our currents are the continents, so the location of our continents. So we know that when the ocean currents make their way through the ocean and they come to a continent, they become deflected. So they're moved around them. That's why when we take a look at this image here, when we see the movement of the current, they often follow the pattern of the shorelines of the continents. Well, we know that as an ocean flows, when it comes to, the shoreline, it's not going to go up on the land, right? These currents can't just barrel through because there's no ocean here. So they have to get curved around and follow the shoreline. Now, what happens is that these currents get deflected in such a way that they start forming these circular currents. So like here in the North Atlantic, we have this warm water current that's coming up and deflected off the coast of America. And then we have this cold water current that's here that's deflected off the Middle East and Africa. And so you kind of get these just like swirling circular currents, and these are known as gyres. So there are 5 major gyres that we need to know about, and we just need to know their location and what they are, which are just these swirling circular currents. So they are named after the ocean they're in and whether they are in the northern or the southern hemisphere. So our northern Pacific gyre would be in the northern hemisphere and it's in the Pacific Ocean. Our northern Atlantic gyre is in the northern hemisphere and it's in the Atlantic Ocean. And then same thing for our South Pacific and South Atlantic, they're just in those oceans. And then the Indian Ocean is in the southern hemisphere, but it's just called the Indian Ocean gyre, so we don't have to differentiate. Now, these will be important kind of when we talk about pollution, because a lot of times, if we remember back from our freshwater unit, we know that humans love plastic water bottles, but a lot of times the plastic actually winds up in the ocean, and they will get caught in these like swirling circular gyres, and particularly here in the North Pacific, there is a place where the currents slow down and the movement kind of stops, and so there's a lot of plastic that just floats out here in the ocean, and it's actually called the Great Pacific Garbage Patch. We'll talk about it when we get there, but there is a really interesting documentary on Netflix if you guys ever want to take a look. So the flow of these gyres, meaning the circular motion that they move in, is opposite directions in the northern and the southern hemisphere. But why? Why is that? And that comes to our third thing that affects our ocean currents, and that is the rotation of the Earth. So today's lesson that we're focusing on, that we really need to drive home, is this idea of the Coriolis effect. So we say that word Coriolis. And this is caused by the rotation of the Earth. And remember, when we say Earth's rotation, that's the spinning of the axis. So the Earth going around on its axis. And this is what ultimately causes day and night. So this causes the currents and the global winds to be deflected. So just like the continents will cause deflection in the currents, the rotation of the Earth will cause deflection as well. So currents will be deflected to the right in the northern hemisphere and to the left in the southern hemisphere. So if we're going to the right in the northern hemisphere, so if you were going to throw a ball or like shoot a paper airplane and you were standing in the northern hemisphere, so let's say we're in North Carolina, because North Carolina is in the northern hemisphere. So if you're standing there and you throw a paper airplane, you might be able to throw it perfectly straight, but it's not going to appear to move in a straight pattern because we're rotating. So even though the trajectory of that paper airplane is straight, it's going to appear to curve to the right. Now, if you're in the southern hemisphere, you could do the same thing and it's going to curve to the left. Now, what this means is that hurricanes in the northern hemisphere, because everything gets directed to the right, we're going to see hurricanes that spin counterclockwise in the north, and then we're going to see hurricanes that spin clockwise in the south. So counterclockwise in the north, and then clockwise in the south. So there are a couple of videos here that I highly encourage you to watch on the Coriolis effect. I'm going to go ahead and pause this because I'm not going to watch it. But these can help kind of explain that a little bit better than me just telling you about it, because it's a good visual for you to have there.